How viruses shape our world. COVID-19 is a reminder of their destructive power, but they're crucial to humans' development and survival. Let's imagine planet Earth without viruses. We wave a wand and they all disappear. The rabies virus is suddenly gone. The polio virus is gone. The gruesomely lethal Ebola virus is gone. The measles virus, the mumps virus, and the various influenzas are gone. Vast reductions of human misery and death. HIV is gone, and so the AIDS catastrophe never happened. Nepal and Hendra and Machipol and Sin Nombra are gone. Never mind their records of ugly mayhem. Dengue gone. All the rotaviruses gone. A great mercy to children in developing countries who die by hundreds of thousands each year. Zika virus gone. Yellow fever virus gone. Herpes B carried by some monkeys, often fatal when passed to humans, gone. Nobody suffers anymore from chickenpox, hepatitis, shingles, or even the common cold. Variola, the agent of smallpox. That virus was eradicated in the wild by 1977, but now it vanishes from the high security freezers where the last spooky samples are stored. The SARS virus of 2003, the alarm that we now know signaled the modern pandemic era, gone. And of course, the nefarious SARS-CoV-2 virus, cause of COVID-19, and so bewilderingly variable in its effects, so tricky, so dangerous, so very transmissible, is gone. Do you feel better? Don't. This scenario is more equivocal than you think. The fact is, we live in a world of viruses. Viruses that are unfathomably diverse, immeasurably abundant. The oceans alone may contain more viral particles than stars in the observable universe. Mammals may carry at least 320,000 different species of viruses. When you add the viruses infecting non-mammalian animals, plants, terrestrial bacteria, and every other possible host, the total comes to lots. And beyond the big numbers are big consequences. Many of those viruses bring adaptive benefits, not harms, to life on Earth, including human life. We couldn't continue without them. We wouldn't have arisen from the primordial muck without them. There are two lengths of DNA that originated from viruses and now reside in the genomes of humans and other primates. For instance, without which, an astonishing fact, pregnancy would be possible. There's viral DNA nestled among the genes of terrestrial animals that helps package and store memories, more astonishment, in tiny protein bubbles. Still, other genes co-opted from viruses contribute to the growth of embryos, regulate immune systems, resist cancer. Important effects only now beginning to be understood. Viruses, it turns out, have played crucial roles in triggering major evolutionary transitions. Eliminate all viruses as an thought experiment, and the immense biological diversity gracing our planet would collapse like a beautiful wooden house with every nail abruptly removed. A virus is a parasite, yes, but sometimes that parasitism is more like symbiosis, mutual dependence that profits both visitor and host. Like fire, viruses are a phenomenon that's neither in all cases good nor in all cases bad. They can deliver advantage or destruction. Everything depends on the virus, on the situation, on your point of reference. They are the dark angels of evolution, terrific and terrible. That's what makes them so interesting. To appreciate the multifariousness of viruses, you need to start with the basics of what they are and what they're not. It's easier to say what they are not. They're not living cells. A cell of the sort assembled in great number to make up your body or mine or the body of an octopus or a primrose contains elaborate machinery for building proteins, packaging energy, and performing other specialized functions, depending on whether the cell happens to be muscle cell or xylem cell or neuron. A bacterium is also a cell with similar attributes, though much simpler. A virus is none of this. Saying just what a virus is has been complicated enough that definitions have changed over the past 120 some years. Martinus Bendrick, a Dutch botanist who studied tobacco mosaic virus, speculated in 1898 that it was an infectious liquid. For a time, a virus was defined mainly by its size, a thing much smaller than a bacterium, but that, like bacteria, could cause disease. Still later, a virus was thought to be a submicroscopic agent bearing only a very small gnome that replicated inside living cells. But that was just a first step towards a better understanding. I shall defend a paradoxical viewpoint, wrote the French microbiologist André Louf in The Concept of Virus, an influential essay published in 1957, namely that viruses are viruses. Not a very helpful definition, but fair warning. Another way of saying unique unto themselves. He was just clearing his throat before beginning a complex disquisition. Luff knew that viruses are easier to describe than to define. Each viral particles consists of a stretch of genetic instructions, written either in DNA or that other information bearing molecule, RNA, packaged inside a protein capsule known as capsid. The capsid, in some cases, is surrounded by a membranous envelope, like the caramel or on a caramel apple, which protects it and helps it catch hold of a cell. A virus can copy itself only by entering a cell and commanding the 3D printing machinery that turns genetic information into proteins. If the host cell is unlucky, many new viral particles are manufactured. They come busting out, and the cell is left as wreckage. That sort of damage, such as what SARS-CoV-2 causes in the epithelial cells of the human airway, is partly how a virus becomes a pathogen. But if the host cell is lucky, maybe the virus simply settles into this cozy outpost, either going dormant or back engineering its little gnomes into the host gnome, and bides its time. This second possibility carries many implications for the mixing of gnomes, for evolution, even for our sense of identity as humans, a topic to which I'll return. One hint for now, in a popular 1983 book, the British biologist Peter McDowell and his wife Jean, an editor, asserted, no virus is known to do good. It has been well said that a virus is a piece of bad news wrapped up in protein. They had it wrong. So did a lot of scientists at the time, and it remains a view still embraced, understandably, by anyone whose knowledge of viruses is limited to such bad news as the flu and COVID-19. But today, some viruses are known to do good. What's wrapped up in the protein is a genetic dispatch, and that might turn out to be good news or bad, depending